Holy moly. I almost regret starting the stream. Feeling a bit queasy. I'm sure we'll manage. All right. Okie dokie. Let's turn it down a bit. So, dual contouring seems to not quite be what I need. So we are moving on a bit. I've already re-implemented my old solution, which I don't know if it'll work. I don't know if this is the right version, but I guess we'll just have to find out. But all we should have to do here now is assign all of this to we have to go through it actually. There's quite a lot here that's wrong. I don't know if this should be here. But I was also considering something. We might right now we have 7 values, which is actually 8 values. But I was considering maybe reversing it. Whoops. Or not reversing it, but signing it. But I don't know if that's worth it. And I don't think it's actually needed necessarily either. It was just a thought I had. Because right now, we have 7, right? But I think signing it actually is less. Because if I sign it, like right now, we have 0 to 7. That's 8 values. But if I sign it, we have 0 to 3. That's 4 values. And then we have -1 to 3 as well. That's 7 values. That's less values, right? But it does mean that we have converted it from... Like, it's kind of weird because 7 is an uneven number, but this is actually an even number in reality, because the way it should work is that if we have a dirt block, 0 means 1 in terms of volume. Because if it's not a dirt block, or if it's a dirt block and it has 0 volume, that means it has 1 volume. Because if it has 0 volume, it wouldn't be a dirt block, basically. Then it would be air. That's basically how that works. And the issue is that if I don't change this to a signed value, then we can't have a center. Not being able to have a center, I think, is a huge problem. Because we need to be able to have half a tile of something. But right now, let's see. Do these go between 1 and 0 or 1 and -1? Yeah. And that's the thing. If these go between -1 and 1, then we can use a signed integer to convert that. 0 is just 0, and anything else is a signed value. And how does it typically work? ChatGPT, in assigned integer is a bit flipped to positive when the value is negative or positive. In C#, which bit is usually the sign? Always the most significant bit, so that the last one. Yeah. All right. So that's... That's 3 per bit field. We could bake some more in here, but I don't think it's necessary. That's 3 per bit field. And we're using... Well, in reality, I do think we should be using 5 vertices per face instead of 4. I like that a lot better, personally. Like, it might run worse, but you can do so much more with it. Like, you can have balls and stuff. can have hills. So the question is, do I want to have 8 or 12? Let's just start with 8 for now. Let's just get it to work, and then we can expand it. And how should this work? Because this, doing this is going to set voxel matrix, voxel voxel matrix am I dumb? Oh yeah, it needs to be here. Voxel matrix XYZ dot vertex equals new vertex container, and then it's gonna have a bunch of shit there, but we'll have to remake this. You know what? I think I'm gonna back up the project before we do any bullshit here, which might take a little while. Dual contouring. No, this program is called Not Valheim Real. That's the one. Assets, scripts. We only need the scripts folder. That was it? That was fast. Well, I guess scripts are lightweight. It was not even a megabyte. That's it. We have the vertex container there and everything. All right. So this is backed up. Now we need to just completely butcher this, because this should now be I guess a list. But either way, we can do some commenting out. We need vector 3 positions. Let's do it this way. B0. Like that. And then this is a little tricky. Actually, I want my bit fields back. Let's get those back. Now, from what I understand, when you want to do bitwise operations, it should actually be on integers, not uints. But I don't think it actually really matters either. I think they're both fine. But I think the operations assume it's an int, not a uint. But from my experience, it doesn't really matter. But from my experience, it does matter in terms of sending the integer to the GPU. Because then sometimes the conversion isn't implicit. But I feel like it's more often that I'm using uints on the GPU for like no reason really. And I'm using an integer to set the uint, and then it becomes fucked. Something like that, like I don't know. Which doesn't even make sense. Like it literally doesn't make sense, because as long as the int is positive, it's the exact same. Bitwise, it's exactly the same as a uint. Like the only difference is that if the bit is negative at the end, then it's an int, really. Monkey. So, now this is gonna suck ass, because what the fuck are we gonna do here? So, basically, we have to set these vertices. And in order to do that, it needs to be something like vert bitfield 0 is, we need to set the v, or we need to use like vx, but this is a float, right? It's a float that goes between 1 and -1. So what we need to do is we need to multiply it by 3. let's do it here. Let's say int value, or yeah, int value equals this. Why is it throwing a fit about this? Yeah, because it's getting implicitly converted to a float. So we need to convert it to an int after. And then we need to say bool. No, let's say int is negative equals if value is less than 0, then 1, else 0. And then we can simply okay, no, my neighbors are just making some noise. And then we say value equals map.sign value. Plus is negative pointer 3. Right? Or is it 2? Yeah, maybe it's 2. Yeah, because it's the third bit, so it's 2 bits over. Right? It's this one. 0, 1, 2. Yep, it's 2. And then we say value. Birth bit field equals value. And then we repeat this. For y. Oh my fucking god, are you kidding me? This is gonna be so much repeated code. Holy shit. No, this just can't be worth it. Can I write this in a way? Can I write this in one letter or in one line? In some way that doesn't suck? I don't think so. Or maybe. Let's try. So we want this. This is the value we want to set. Except I want this value to be signed. Or no, not signed. I want it to be absed. Plus b0.x less than 0, then 1, otherwise 0. Pointer 2. Is that enough? Plus, I used sign incorrectly. That was supposed to be abs. Yeah, maybe if we do that, I can do this without blowing my brains out. But the reality is... we fit 9 in the first bit field. So this is how much it is that we have to write. But let's actually set up the first 3 first. So it's v0, y, z. And then that's what it looks like. And this is 3, 6. Then this is v1, v1. And this continues 9, 12, 15. E2. $18, 21, 24. And that's that. That's Bitfield 0. This is Bitfield 1. And so this is now 3, 4, 5. And then it's just done. Bitfield 2. This is 6, 6, 7, 7. And the last one doesn't exist. Yes, that's what we need to do. No. Yeah, no. It's fine. I think converting to an integer truncates, I think. Like so. And for the rest, I think we almost have the infrastructure to deal with this. We can get rid of that. We're not gonna use dual contouring anymore. Vertex dot position. Does not exist anymore. So let's go up to dual contouring here. So here instead now we're gonna do calculate voxel config. I think X, Y, Z. And we go down to right. Voxel index. Voxel data is index, brick index, vert bit field 0, 1, and 2. We are good to go. At least go over to the tracer, I believe. Export voxel data. Yeah, okay. We don't need that. Here we just need to say vert bit field equals vertex voxel matrix xyz dot vertex dot bit field 0. This is a uint. Alright, let's go and set these two uints as well. That's not good enough? You see, this is what I mean. Fine, whatever. Let's set it to uint here. Like that. Let's say if voxel matrix x, y, z dot vertex does not equal null, then we do this. How about now? Yeah, this whole section, this. Excuse me? That compiles. And then we have to go and we have to read the bit fields now. And I think we can do the same method here, except we have to change the triangles. But I mean, we can keep this here, but the triangles are now based on this, the old one, the classic. And that means that we actually need to have all triangles. So that's 12 triangles. So, the first triangle is 0, 3, 1. Second one, 3, 2, 1. Next one is 0, 307. Maybe? And the next one is 0, 4, 7. Not sure. Four, 0, 5, 0, 1, 5. Three, 7, 2, 7, 6, 2. One, 2, 5, 2, 6, 5. Seven, 4, 6, 4, 5, 6. Those are the triangles. Good work, actually. Oh, yeah. some tea left. So right now it's crashing because we're checking neighbors, but I haven't told it to not check its neighbors if it's the edge of the world. How should we handle that? I think I'm gonna say if x equals 0 or y equals 0 or z equals 0 or x equals world size in voxel dot x minus 1 or y equals world size in voxels dot y minus 1 or z equals world size in voxels dot z minus. I actually don't know if it is minus 1. Then we just return. Fuck it. We don't need to calculate the edge-most voxel. It's that simple. We're getting something, but it's not something good. But if you pay attention, you can see that we actually have the world. It's just the vertices of each voxel is just jumbled, but the world is actually correct otherwise. So the question is, what is wrong and why? Kind of curious. Oh, you can't see. Also, at the moment, it's running just as poorly as when I was running code the other way previously, but whatever. This here might be an issue. We have a count, but we actually don't have a try count anymore. So let's remove the try count entirely. But that also means that we have to do all of the tests here. That's the problem. That looks a lot different. But not different enough. So what the fuck is happening? Well, it's quite simple. The vertex config is just wrong, but that's a lot more promising. The question is, where is it? Where is it wrong? Yeah, we're missing some things. We're missing the initial setup, I think. Because here you can see we're setting v2.x to v2.x minus 1f plus v1.x. v1 is the other end. So what we haven't done here is we haven't set up the vertices for the size of the voxel, which wasn't part of my comments, which is a little unfortunate. So here we're getting all the voxel data. And we're setting up a bunch of VAs. This is all way too new. What about here? Yep, this is it. So we have to say int volume equals voxel matrix xyz dot volume. See, here we have volume, but we can do get volume maybe. Yeah, that's just fetching the volume contents only. That way we get the volume. And then we want a float volume divided by 7. And then we need to set up all of these vectors. v0.set normalized volume, normalized volume, normalized volume. And then all of these need to be a specific value. So this is negative, negative, positive, positive, negative, negative. On the Y side, it's negative, negative, positive, positive, negative, negative. And Z is all four last ones are negative. Is that all I need? That didn't do anything at all. So what are we seeing? We're seeing some bullshit. Oh, I know. I have an idea what the issue is here. Get triangles. So, this is not as simple anymore. So this is now, all of these are 5, right? Or is it 3? Yeah, it's 3. And that means that all of these are divided by 3 now. All of a sudden cringe. Oh, definitely more voxels. Wait, am I stupid? Look, this is 7, which is 8. But then 3, that's actually 4. No. But we still have... Yeah, we still get 7 values. No, we get 7 instead of 8. That's how it was. I feel like I should be dividing it by 4. Well, actually, I don't know. I think we actually only get... Yeah, no, this is correct. So it needs to be like this, right? And then after we have divided it by 3, we need to further add another operation, which sucks ass, but we have to do it. That says v dot... Well, let's just copy this whole thing. And it's gonna say v3 6 9 3 6 9 3 6. And then we need another parentheses, because when you're using bitwise in HLSL, it needs to be parenthesized, otherwise it doesn't work. And 1. And then we have to take that and we have to multiply by the negative value of 1. Now that doesn't work. Then we'll just end up with 0. Fuck. How do I turn it negative? What I'm doing here is I have a signed value. So I need to take my third bit, and if that bit is 1, then the value needs to be value is then negative. I have an idea. We can do this. Multiplied by 1 times we multiply it by -1 times no. Hold on, there's a mathematical trick here. I'm just too stupid to think of it immediately, but I can feel it, I can see it. You do like... because we don't want to multiply by anything, really, when the value in the bit field is 0. Which means that we multiply by 1 minus the value times 2. Right? So we multiply by 1. If this value is 0, then we multiply by 1 minus 0 times 2. And then that's just 1, because 0 times 2 is just 0. So we're not subtracting anything from the 1. And then when we multiply by 1, we don't change anything, right? This should be like that. And like that. We can really remove that. I think that should be okay. Yeah, it can be a little annoying. Can be. And then we need to move over and do the same thing here. Especially, note when I press the parentheses button here. Oh no, never mind. But when I press the parentheses button over here, on the right, it auto... What's the word? It auto corrects it. It auto formats it. So every single time I change anything here, I have to hit... like, look now when I'm gonna paste here. Every time I have to hit undo as well. And like that. And it's not done because this is... This is actually not 369. Because it's like this. This is 6. And this is 9. Which means this is 12. $15. 18. 21. 'Fuck, this is wrong. I think. Or is it? 0, 1, 2. Yes, it's wrong. So it's actually 2. 0, 1, 2. 3, 4, 5. The next one is 5. Five, 7, 10, 13, 16, 'I fucked this one up. This is 10. No, it isn't. This is 3, 5. So that should be 7. And this is 3, 4, 5. Oh, this isn't 7. This is 6. This is 8. This is 3 to 5, this is 6 to 8. 6, 7, 8. This is then 9 and 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There we go. Easy. And then these values actually become the same. Like that. Same thing here. And here. And this one bugged there. This is also kind of incorrect now. But I think we might need to do a time swap 0.5. Because this should result in a value between -1 and 1. While the system currently, I think, is designed for -0.5 to 0.5. Doesn't work. There's like no difference either. I mean, there is a difference actually. The colors that we see on top are different now, but it's still fucked. Oh boy. Why can't I see voxel volume? Why is the voxel... What the fuck is happening? Why are we seeing voxel volume all the way up here? When it doesn't start until down here somewhere. Let's see. Let's go here. Here we're checking for a non-empty vert bit field. Which is really strange that we're finding up there. But let's try checking for a color index that is not empty. But that's actually incorrect. But let's see if that makes any difference. I wouldn't think so. But now at least it's more correct in terms of what we're supposed to be seeing. Because now when I look at a voxel, we can tell, like, yeah, okay, this one has a volume of 1. And we can see the highlight didn't. I saw the highlight work like once. You can see it's like all in a little knot. It's not very correct at all, is it? So the question is, what is the issue? Where is Tri-A actually set up? Fuck's sake. At the start here. Try array 12. Fuck. Okay, we just got kicked out of Restream. That's cool. We're back. Oh, yeah. That didn't really make much of it. Actually, I mean, it kind of changed the color, but it didn't change. All right. Can we figure out what the issue is here? The order... clearly fucked. But this here, this shouldn't matter, because I'm just setting up the triangles, and then we're just checking them for hits. And if they don't hit, then they don't hit. That's it, really. And get triangles here. V0. We're just setting it up in the same order that it's saved. So here, this is also completely order agnostic, I would say. More or less. I think this should be correct, but I guess we'll go here and find out. So this is X. This is bottom left. V1 is left top. 2 is right top. Wait, hold on. Yeah, I confused it. This is the opposite of the way it is. I used Y as... Or I read it wrong. That's all there is to it. The same thing here. This should be the opposite. But I kind of doubt that's enough, but we'll see. We'll see what that does. Nope. How did it make no difference? Oh. No, none at all? Okay, it didn't make no difference. It looks slightly different. No, it doesn't. Alright, let's check again. Bottom left, top right, bottom right, further right, further bottom right, or back bottom right. Top bottom right, top bottom left, or yeah, whatever. Yeah, it's the correct order there at least. And here we're doing some other weird things. Here it's set to 0.5. I think this was some kind of test. And it's also set to -1. But I actually don't know which one was correct there. I also want... I want to say something like... If... If alignment is 000, I think we should also skip. And if we do that, then we can potentially skip through this. Maybe. Fuck. Wait, did I do ores? Oh. We're not doing the alignment step anymore. That's pretty big, because that's a huge part of this setup. We ended up with a breakpoint inside of there. Cool. So we're now at Z1. Which makes sense. Why 23? I guess. Normalized volume is 6, so we get a normalized volume of 0.8571. So this becomes... Yeah. This is our alignment. So we're gonna set V1 to be shifted down. So this is now 0.7. So this was shifted the remainder of this. Right, so now we have this is now -1. This value is now 6.5. Yeah, okay, this is where it's wrong. See, I'm calling volume contents here. But it's not actually normalized. This needs to be divided by 7. And unfortunately, it needs to be divided by 7 on each one of these fucks. Now, there might be a case for caching all of the neighbors instead of doing this shit. All right, let's try again. That did nothing. I love it. Like you change something, it does literally not a single thing. Nothing has changed. And what I'm looking for is like, can we get a volume like differential somehow? But it doesn't seem like that's happening. Oh, let's start it again. Let's see if we can get a surface voxel. Because now we can actually inspect how a specific voxel is being created. So this is voxel 54, 35, 18. Why is this annihilated? So let's set conditions. X equals 54 and Y equals 35 and Z equals 18. Oh, I think this is gonna take forever now because... Yeah, okay, we found it. When it has to evaluate the breakpoint every time, it's way slow. So, we're currently at 54, 35, 18. We fetch the volume. It says 6. It's supposed to say 6. Normalized volume is set to that. Go through that. That's all good. The current alignment should be Y minus 1. And it is. Good. So we're gonna set V1, that's a top. V2 is a top. 5 and 6 are both tops. So those are being set to... Yep, the remainder. And then these are the bottom Y. And when I say that, I mean these. These are the bottom, and these are the top. So the numbers, top 1, 2, 5, 6, 0, 3, 4, 7. So we're setting the bottom ones to -1 so that they're all just smack dab against the wall there. And that's how it should be. And then we reach this place. And now we need to check the volume contents. 6, 6, 5. Those are not 0. So we're gonna be taking those volumes and we're creating an average. which is now 0.82. And then we're checking above to see if the volume is 0 there, which it is. And then we are setting V1 to this normalized value. Yeah. And then here we're doing the same thing, except we're checking a few other corners here. Normalized value is 0.85. V2 is being set. Right now V2 is... it looks pretty good. V3 also looks correct. Normalized value 7.8. So here V5 is being set to 7.9. Yeah, that's correct. And V5 is correct. V4 is also correct. Here we're setting 6. V7, that's correct. V6, that's correct. Here we're setting side averages. We're checking X1 plus our volume content. This is there now 5.5. All right. Yeah, this needs to be... this needs to be multiplied, because here now this gets set to 5.5. Yeah, okay. And this is why it becomes garbage, because right now I don't actually have any protection. Which we can add some protection down here, but it does make it slower. And what I mean with protection is that I'm currently just storing the float of each axis in each vertex as just a value. And then I multiply that value by 3 to get the bit value that I want. But the only way that's accurate is if the value in here, in the vertices, never exceed 1 or go below -1. So if we set one of these to 5 by accident, then that's going to become a 5, and then that's going to create garbage information in the when we bake it into the bit field. That's, I think, why it's becoming weird. Am I reading volume content anywhere else? Yeah, here. damn it. Literally no change. It's so depressing to see when it does that. It's just nothing. Like nothing. At least change something, bro. Like something. I beg you. Anything. But I actually feel like it looks a bit better in some. No, it doesn't. Now it's exactly the same. All right, let's step through it again. Setting this. So far everything was good. And then we reach here. Now have a normalized value there. Yeah, that's okay. I'm not really sure about what we're doing here, but seems fine. Like it's not creating any knots or anything. And then here, setting extremes. So far, so good, in my opinion. But if this isn't the issue, then where does the issue begin? I don't think we'll be doing any of those. So now we get to here. So here we have vertex 0 is -1, -1, -1. Vertex 1 is -1, 0.82, -1. Vertex 2, 1, 0.86, -1. B3, 1, -1, -1. B4, -1, -1, 1. B5, -1, 0.79, 1. 6, 1, 0.86, 1. 7, 1, -1, 1. That looks perfect. That's a cube where the top has just a slight lean. That's exactly how it should be. So why is this, like, what are we gonna get here? The first X this is 3. If it's less than 0, then 1. Pointer, pointer 2. But I think we... if we type in 16, what do we get? That's wrong, though. Does addition happen before bitwise? Is this an order of operations issue? Kind of looks like it. I think we might have to do something like this here. Let's give that a try. Because it looks like it should just work. That looks promising as hell. Ooh. Other than the fact that, for whatever fucking reason, there's no proper lean, this looks... I mean, it looks kind of correct. I mean, it looks... I don't know if correct is the right word, because if we look at this one, it says volume 1, and then the next one, like, it's not very smooth, is it? This is volume 7. What is happening there? Volume 6, 6665, 4. Like, I can see that it's going down. 2, 1, 1. And then there's a huge leap. So what's causing that? I feel like that has to be what I'm doing here, right? Like, we're extracting from the bit field the first 3 divided by 3. Does this not work? Like, I'm extracting 2. And 1. Right? Feel like it should work. Is it this stuff that I'm maybe shouldn't be doing? Kind of better in some ways, worse in others. As you can see, now we have a better, like... But for some reason... I think there's a floating point issue here. Which I'm not too surprised about, if I'll be perfectly honest. I think we might... we might want to do this separately. Because I don't think it really matters if you use up registries here, if they're discarded. But I'm not sure if that is true. Well, we are getting closer at least. I just feel like see, the reason I'm not like super hyped about doing more stuff here is because it's gonna... Let's just do it, but it's gonna look like it's gonna be super annoying. Int3 v0 I equals int3 So we're gonna have to do this 7 times. Well, we can just do this, right? Like that. That way we now have the positive value and we have the integer here. And then we can write if vo1 voi.x equals 0. No, equals 1. then we can say vo dot x times -1 or -1. And then we're gonna do that for y, and we do that for z, and then we're gonna format it like this, despite it fucking despising me for it. But we're still just seeing stuff like this, which is obviously no good. But we might still be operating at -0.5. But then we end up with this. So there's like no winning here for some reason. I don't really understand what's happening. Why are we getting this? Why is this a 6? Like, I guess this one is actually kind of correct. 5, 4, 3, 2, 1. But see, it's like it only goes down to 0, and then the negative values don't really properly exist, except for on the corner. What am I doing wrong? And you can see, like, it feels like it's only really going down in certain places. Like here it's 3, 3, 3, 4, 4, 4. And then when we reach 5, it's actually going up. Right. Four doesn't exist. What is the reason for this? I feel like this should work. Let's switch this to 1 again. Why wouldn't that work? That should be the only places that are affected. Unless, like, get triangles. Yeah, they still have 0.5 there. This should make no difference. It should be the same. It should be exactly the same. The fuck? Like, what's the problem here? As you can see here, I'm like... Like, how is this happening? It's like whenever I try to exit a voxel, it's returning that we are actually colliding with something. It doesn't really make sense. Because if the green can render like this, right? Then the vertices don't really exist up there like that. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Why is this happening, man? This is such bullshit. Like, what is this? I genuinely do not understand at all. Okay, let's use our brains here. So this is Z. I'm currently heading Z in the negative Z direction. So this is Z front. So it's actually colliding. It's actually colliding on entry. How is that possible? But it's not doing it like here. This one is just fucked up. It's colliding on entry, kind of here. Like if you look at this, it's actually leaning, kind of. I feel like this is like a projection issue. What are we doing here? If mask and raise step equals 1, then -1, otherwise 1. Otherwise, we're setting it to temp ray position minus floor temp ray position -1. Here I have a ×2. I think that makes more sense. Like that. Hello, Knight. What are we doing? I'm basically going back to my first solution, which is basically just calculating all of the neighbors. But I'm doing it on the CPU instead of on the GPU. But something is messed up and I don't know what it is. This is actually better than what it was. Ironically. So this runs really bad, which is very surprising. What if we do that? Okay. Without the inspector, it runs at 400. With the inspector, it runs at 120, 150. Only 260 with shadows, though. But it's bugged now, so it's impossible to tell. I was expecting better, I'll be honest. Why is this happening? Like, it's still not right. Am I stupid? Hold on. Let's see if I'm stupid. No, I'm not stupid. No, it doesn't matter. I don't know. It's just behaving so oddly. I feel like... I don't know. The first, we're checking the first 2 bits, right? Like that's what 3 is. 3 is bit 1 and 2, or bit 0 and 1 rather. And then we shift 3, and then we check the first 2. Like, I don't see any issue here. Yes, I am skipping a bit on purpose. It's assigned, I have 3 bits for each vertex, and the 3rd bit is the sign. And the reason I'm using a sign is because now I'm calculating everything down here. This is a bunch of bullshit here, but I'm basically calculating all of the vertices on the CPU, and that uses... I'm using values from -1 to +1, so I wanted to use the sign because then I can just take the negative value and just abs that, and then we just store that it was negative. And also because it gives me a center. Because then I can have a 0 that's centered, and then I can have the rest of the value goes out. Because before I was having an issue with not having a center because I had 8 values. But now we have 7 values. Yeah, no, basically all I'm doing now is we're going through every voxel on creation, and we're just comparing it to its neighbors. I'm also giving it an alignment. The alignment means that if you have a voxel and it has a neighbor down but no neighbor up, that means it's aligned down towards this one. That's so that the surface sticks down towards the non-surface. And then I do a bunch of calculations based on that. I shift the vertices down based on... because I initialize all the vertices as just like a square or a cube in the middle based on the size of the voxel. And then I shift it, and then I like stretch it out towards its neighbors. Then we create We make it lean by checking each corner's like average volume and all kinds of stuff like that. And I looked at it, like I stepped through it, and it looks accurate. But maybe we should check one of these, because the one I checked had a volume of 6, and you know, that seems okay. But you can see, as I'm going along it here, this is volume 6, 5, 4, 3, 2, 1. And it barely changes, and then, bam. You know, it's almost more than half of the size when we actually move down one Y value. And that's what's so weird. It's like my whatever I'm doing to set it to negative isn't working at all. No, but yeah, we're making terrains. You can see this is the full size of the entire voxel bound. So it's only going to half, if that. So let's check here. Where do we have? $44, $35, $25. Let's check that. $44, $35, $25. Because the question is, are we failing to set the Are we failing to set 1, 2, 5, 6 to values that are below half on the CPU side or on the GPU side? That's what we need to figure out now. I think it works just fine here. Wait a second. No, it should work, right? Like, here I have float 3s, and I'm trying to set the Z to something here. But that should work, right? Like, it's not like... Yeah, no. Sometimes I get a little confused. I'm like, okay, is it just modifying the version that we fetched? But no, this should work. I don't know. Yeah, because I was literally doing it this way before, like I was setting it like that. So it should work. Either way, let's see what this voxel says. There's unfortunately a lot of steps to step between, but... Alright, we're here. The volume is 1. The normalized volume is 0.1428571. Then we set all of the vertices to be that number, except some are positive, some are negative, right? So it's the volume in each direction. And these numbers are fine. Then we go in here, apparently. It's aligned down. The Y alignment is -1. And what we're doing here is we are shifting the vertices so that the vertices that are down are against the wall or against the floor, and the other vertices are shifted the remainder of the whatever the remainder was between here that we just shifted. So this is now it goes from 0.14 to negative 0.71. So this obviously already works. Here we're setting normalized values. Is it this? Did we actually need a -1 here? I think this is the issue. The normalized value here is set to the volume. Actually, I think this should simply come before we shift. A lot of commented code here. I'm scared of deleting it because I don't know if I need it. But we set the averages first. Then here we're doing something similar. But let's try putting it here. Then we run it once. It's better, but it's not good. Unfortunately, I'm kind of forced to redo a bunch of things here. I wonder if I have a better version. Like, what is this? What is happening? What is this? Yeah, I think this... This is too new. About this one. Script. I feel like this one should work. And here we're shifting first. Then we're setting averages. And it's all voxel data times 0.25. Except for y. Here it's times 0.5 minus 1. It was set to that before. Alright. Let's unmove it. And then let's go to y. And we'll set this to 5. And we'll subtract 1f. And we'll subtract 1, I guess. Well, that didn't fucking work. Though... I think the 1 should be here. Perhaps. If we shift places, this is 7 divided by 7, and this is minus 1. I think that makes more sense. Let's see what happens then. Oh, Explorer crashed. Based. Oh, Chocho, how's it going? It's actually maybe correct now. Except we have a lot of these edge cases that are bad. I think ultimately I'm going to have to I think we're gonna have 5 vertices per face instead of 4. Because there are so many issues otherwise. I'm not 100% convinced, but I think so. Going to become a Knight of the First Degree in Knights of Columbus tonight. Well, congratulations. Sounds good, dude. This is 1. And this is 7. It doesn't feel quite like it should. It's hard to say. And I'm not really sure how to handle this, because you can see stuff like this shit, right? Like this is basically impossible to solve. The only way I can solve this, because if you think of this from like a UV perspective, the only way this is solvable is if I make like one side have dominance. So that instead of this being like this, where we have, because red is left. Yeah, red is left, blue is front, green is top. So here you actually have front and top like divided. So the only way to fix this really is to make top have dominance. So that instead of having this split here, we just take this vertex and shove it down here. Same thing here, we just shove it down here, right? And I think, like, I don't necessarily like that, because that means that I can't properly have vertices from the, like, they don't behave the same from all directions. That's what I don't like. But this would solve it in like the most practical ways, like or in the most ways where it's a problem in practice. Because I don't necessarily think that adding a 5th vertex would really solve anything there either. Because the only way to solve this with more vertices is if you add vertices to the edges. And I don't want to do that. I already tried that, it was ass. The corners are the problem. These corners here are unsolvable. You have to hack it. This is a hack solution, I think, no matter what. Because if you look here, the I'm a little confused why this one is fucked, but okay, maybe not. But it's the fact that you have like this one here needs to become like flat against the ground. But in reality, the voxel that is below here would really need to be lower as well. But it can't be. So you end up with really weird edges in some of the corners that end up creating like if you have a slope like this, right, it ends up looking like this instead. Because you have these edges that are unfixable. So the only way to fix those is to create like filler tiles. And I already solved this. I already implemented it once. I honestly don't remember why I had to trash it last time. But there were issues. And I think a lot of the, like, I think almost all of these problems that we see here were issues that made me like trash this. Like the fact that I can't really do this. And I have to choose like the top to be dominant here. We have these annoying edge thingies. And when you use this solution here, the 8 vertices, you also have the issue of the seam, right? You have to calculate how should we split like every single face. We have to calculate how should it be split. And that's why I'm not really sure, because I am leaning towards adding central vertices, but I don't know if it'll actually like solve the issues entirely, because what you end up is with corners that look like this, right? You can choose between this or the same, but from this one you get like a straight line, and then you have it's like this, and then you get that. Right. You can choose between these two. But if we have a central one, I don't think it would really solve the issue, because what we'll get instead is we'll be able to do this. Right. And I could move this one down or up or whatever. It's really just easier, but it also comes at the cost of it's twice as heavy. It's literally twice as heavy to render. And the current solution doesn't create like a surface net. It's all boxes. So that means that instead of 12 triangles, we have to make 24 triangle checks per voxel. And let's be honest, that's kind of dog shit. Now, I do think I could write a culling algorithm. Like once we have calculated this. Easy, how's it going? Once this is calculated, I could write a little algorithm for it to check the neighbors, and then we cull all of the vertices that are not relevant. Because we do have the luxury of doing more advanced calculations and checks, since we're doing it on the C# side now, because it only needs to be done on edit, on creation or on edit. So there is the possibility that that could vastly improve performance, but that concern really only comes after we have figured out all of the issues. And I have already solved all of these. In one way or another. I'm just thinking, because I remember there were problems that I just couldn't, like, I don't remember which problem exactly made me move to another solution. But either way, I would like to have the central vertex just so that you can shape the voxels more. So otherwise you are stuck with squares. Like even if you make smooth squares, you're still stuck with squares. Like you can't make a very beautiful circle or sphere, but you can make a sphere. And you can also use other algorithms. Like even with just 8 vertices, we can still make circles, right? Like it really just depends on if we just go and like get a sphere tracer and just like limit it to the bounds or something. That's doable. But we're gonna stop there. it's too late anyway. Hey, at least it renders. It might be broken. We might have taken 4,000 steps backwards. But it is rendering. That's good. Now the shadows are busted. Don't really know why. It's kind of odd. Let's take a quick look at the light section, see if we can see anything. I don't know, I feel like it should be okay. But it's colliding with itself a lot. Which is not okay. But I don't know if any of the math here is still tweaked for minus 0.5 to 0.5. But I think it should be fine. I think this should be like 0.99999 or something. That doesn't make a difference. This is almost correct, but in reverse. Well, anyhow. Until next time. Thanks, Ryan. Have a good night. Bye-bye.